Hello. In this episode, we will deal with contract testing. You already know what kind of consequences the use of a canonical model or even a simple data model shared between the client and the server can have. In the previous episode, we also analyzed the possibility of using E2E tests to ensure communication consistency in distributed systems. Remember that due to their numerous disadvantages, they can lead to both false negatives and, unfortunately, false positives. Contract tests are aimed at eliminating these problems. You probably remember that most of the instability of the E2E tests resulted, in a way, from the inclusion of business logic validation in the communication test. Moreover, testing multiple applications at the same time in the same environment made the environment unstable and fragile. And it is these two main problems that we will eliminate by implementing contract tests. In the case of E2E tests, as you can see in the attached diagram, communication verification is very direct. The client makes a request to the server responds to this request, and we check if the entire process was completed correctly. In the case of contract tests, we want to test both of these elements in isolation, i.e., we introduce an intermediate element, the contract. On the one hand, we check the compliance of the producer, i.e., the server, with the contract, and on the other hand, the consistency of the contract with the client's expectations. As you can see, these tests can coexist with each other. After verifying communication using contract tests, we can, for example, for critical business paths, perform E2E tests to confirm the correctness of the entire process. What is a contract? The contract is a kind of contract concluded between the producer and his clients. What can such an agreement look like? The server says that making an HTTP GET request to it to the address /courses/DNA with the accept header with the value application/JSON will make the server respond with the HTTP 200 OK status. It will reply with a content type header equal to application/JSON and a response body that contains a name field with the value DNA and a status field equal to active. The greatest value of this contract is when we are able to verify the correctness of both of its parties. We create a simulator of our server to which the client can make requests. Not to a physical application that may not work for various reasons, but to a locally exposed stub that always works and always responds correctly. If we can verify if the server responds exactly the same as its substitute, for example by generating an automatic producer's test, then we have verified compliance of both parties. And if the server is compliant with the contract and the client is compliant with the contract, we have verified that the server is compliant with the client. The first artifact of our contract, in this case HTTP, is an automatically generated test of this part of the producer, i.e., the server. What he is doing. Does a GET request on /courses/bottoms, obviously with the proper headlines. The server suggests it. This test verifies that the answer is correctly structured. How does this translate into the different layers we will be testing? As you already know, in integration tests, we verify the entire application stack, i.e., the API layer, application and domain logic layer, model, database, etc. In the case of contract tests, we want to isolate the entire application layer and test only the communication, i.e., the API layer in this case. And it is for contract testing that we will only raise the physical API layer that communicates with the embedded layer of the application facade. We can see what it looks like in this pseudocode. We have both setup and test here. Setup creates a mock of the application facade and starts the physical resource of the REST API that will communicate with that facade. In addition, we teach the facade that calling its method getCousDetails with a parameter value of DNA will return some predefined response. The test, on the other hand, communicates with the local client with this locally started API layer. There, it makes a GET request with the appropriate header, receives the response, and verifies whether the response actually had the status 200, whether the content type header was of the appropriate value, whether the name field was DNA, and whether the status was active. In fact, this test outside the setup is generated automatically because everything we need to generate it is already there in the contract. The biggest difficulty in contract testing is keeping the setup. We usually extract the setup to some base class layer, from which all automatically generated tests will inherit. Maintaining this set date is the most difficult aspect, especially when we have extensive answers with a very complicated structure. Here we must remember that the DNA course answers correctly. It is an active course. There will be some other course that is an inactive course. The API design course will be the course that will get a 410 answer, etc. Maintaining this date set, communicating it to all clients, will be the biggest challenge in contract testing. And what does the second artifact look like? The latter artifact is the automatic generation of a substitute, i.e., a stub of a producer that responds exactly as we have verified that our server will respond. The client sends the request in his test, but it is sent to this local substitute. He receives the answer and sees whether he understood the answer correctly, whether he processed it correctly. And again, referring to the pseudocode, we have a setup that downloads application stubs from some repository, in this case courses, and runs the simulator of our system locally for these stubs. Here it runs it on localhost 9001. What does our client's test do? It is on this localhost 9001 that he creates the client of the course's application, performs a request for downloading DNA course details, and checks if he mapped the answer correctly, if the identifier, as it is presented on the client side, is equal to DNA, if the status field is equal to active. Note that we are communicating with a local substitute that always responds correctly, and is not a physical server that may not be available for various reasons or is unstable at the moment. We have shown you what it looks like in the case of synchronous communication, the most popular HTTP communication, but it will work the same for asynchronous communication. In this case, we generate a server test that will trigger the sending of a message on the producer's side, receive this message on such a prepared test queue, and check whether its structure is also consistent with the definition in the contract. At the same time, we provide this test stub queue to our clients, who will somehow be able to trigger the sending of the message, deliver it to themselves, and check whether the message has been properly consumed, correctly received, and whether it is consistent with the implementation of our client's website. When we discussed the REST API, we said that the way to make autonomous changes and not version the internal API is to use deferred changes. I said then that when we get to the contract tests, we will see how our clients can be forced to update, migrate to newer versions. A quick reminder, to make a deferred change, first add a new API version, then wait for clients to migrate from the old structure to the new one and delete the old structure. Let's see what it looks like in the case of migration from the date field to the data time field, as we know it. We do it in several stages. At the first stage, which is the initial state, we have a date field both in the contract and on the server side. We tell everyone that we will be migrating to the data time field. We enter the second stage, in which the contract already includes both fields, both the date field and the data time field. Of course, to be compliant with the contract, the server must return both of these fields, both date and data time. We give clients some time, usually 2 sprints, to migrate to the data time field. And now the power of the contract comes in, because at the third stage we remove the date field from our contract completely. In order not to spoil the production communication, we still return them from the server, but we do not communicate this to our clients in any way in the contract. Therefore, all our clients' tests, which were based on the analysis of the date field, suddenly fail. This is the moment when I force the clients to get updated from the date field to the data time field if they want to go into production. I remain at the third stage for as long as the publishing cycle in my company lasts. If I know that all applications are implemented at least once a month, then I wait a month at stage 3 so as not to spoil production communication and to make sure that everyone is migrating to the new field, which they have to do if they want their tests to pass. After a month after migrating all applications, we remove the date field and the server stops returning it. Note that to make sure I'm not breaking backwards compatibility, I check whether the server is compliant with both the current version of the contract and the previous contract. This is precisely to ensure backward compatibility and verify that I am following the deferred changes mechanism. Let's take a look at what kind of tools are available on the market in terms of contract testing. The first tool is Spring Cloud Contract, which of course is firmly embedded in the Java world, in the Spring world. But due to the possibility of using the Docker images attached to this tool, we can also use it for various other technologies, which you can see by looking at our project. There, Spring Cloud Contract is used both in a Java project and in .NET, PHP, and JavaScript projects. Spring Cloud Contract is immediately built with the microservice architecture in mind. Therefore, it supports both HTTP communication and asynchronous communication, messaging. The second tool is Pact. It's a polyglot tool, natively embedded in a wide variety of technologies, but mostly supports HTTP communication. Synchronous communication is just beginning to emerge there. There is a slightly different approach than in Spring Cloud Contract, where we clearly define the contract. In Pact, we define this contract by writing a server test. Both of these tools are really equal to each other. Analyze both and see which will fit better in your project. Thanks.